Hey guys, it's me Y here, and I'm making another video. And today, I was gonna make a Baby Shark video and watch a whole hour of it. Then I decided I need to learn something. So, what better to learn than all about trains? Lots and lots of trains, guys. So, 40 minutes of me sitting here learning about trains. So, let's get started. Before I start, I want to say I'm not sponsoring this video. They're not sponsoring me. Uh, I'm just gonna learn and see how much I know at the end. So. Yep, another video. I solved Rubik's Cube 50 times last time for an hour and 45 minutes. People can probably do it faster than me, but that's just.
Hello, my name is Carl. Carl, the train conductor. Are you ready to learn all about trains? Well, I hope so, because trains are an important part of everyone's life, including yours and mine. In this video, my train buddies and I will be telling you all about trains. How they were invented, how they work, how fast they go, what the different kinds of trains do, train safety, and many other cool things about trains. So, get ready to learn all about trains. All aboard!
I bet you're wondering just what makes me tick. How does a steam locomotive work? Let me show you. Behind this steam engine is the tender, which holds the coal and water needed for the engine. There are two people in the cab of the engine, the engineer and the fireman. While the engineer makes sure everything is running right, the fireman shovels coal into the firebox in the back of the locomotive. The smoke from the burning coal goes out the smokestack, and the heat from the coal boils water in a big tank in the engine called the boiler, just like a tea kettle. And what comes out of a tea kettle when it gets hot? Steam, that's right. The steam builds up pressure just like air in a balloon. That pressure pushes a piston at the front of the engine, and that piston is connected to a number of rods. These rods are connected to the driving wheels. The steam pushes the piston pushes the rods push the driving wheels, and what do you know? The engine moves forward.
Hey, I'm a diesel locomotive. I don't work the same way that my steam buddy does. Let me show you how a diesel engine works. There's a big fuel tank underneath the locomotive. It holds diesel fuel, which is kind of like the gasoline that makes cars run. Now, this diesel fuel powers a big diesel motor, with pistons and a drive shaft and everything. Again, just like a car. But here's where it gets kind of neat. The drive shaft of the diesel motor is attached to a generator. And want to know what the generator generates? It's electricity, the same kind of energy that lights up your lights and runs your computer and TVs and keeps the food cold in your refrigerator. So this electricity from the generator goes to a number of electric motors attached to the wheels of the diesel engine. At the same time, a fan at the top of the engine forces air down onto these motors to keep them cool. You don't want them to burn up, do you? These are called traction motors, and when the juice hits them, woohoo! The diesel locomotive moves forward. It's all kind of neat, isn't it?
Hi, remember me? I was the guy who showed you what made me tick. But does a steam locomotive run by itself? Of course not. Let me show you how I run. Remember when I told you there are two people in the cab of the engine? The engineer and the fireman? The fireman shovels coal into the firebox, while the engineer makes sure everything is running right. But what are all those dials and handles and knobs for? Let's take a look. The engineer uses three basic types of controls. The throttle or regulator controls the speed of the train, how fast or slow it goes. The reverser, or Johnson bar as it's sometimes called, controls the direction of the train, forward, neutral, or backward. Then there are the brakes, used to stop the train and keep it in one spot. To get the train going, the boiler turns water into steam, and that steam moves the pistons that move the wheels. I showed you that last time. In the cab, the engineer moves the Johnson bar into the forward position. The whistle gives two short blasts to let everybody know the train is about to move. The brakes are released and the throttle is slowly opened up. Hey, we're moving! Actually, there's a lot more to it, but that's basically how it goes. Stopping the train is the same, but in reverse order. The throttle is pulled back and the brakes are slowly applied and we're slowing down. Once the train is stopped, the Johnson bar is placed in the neutral position. And that's all there is to it. So long!
Hey, how have you been? I'm the diesel locomotive that runs in a different way than my steam buddy does. I already showed you how a diesel engine created electricity that feeds the motors that move the wheels, but here's how I'm controlled. The engineer is in the cab. Wow, look at all those dials and handles. Now, those dials show things like air pressure for the brakes, how much electricity is being made, and, most important, the speed. But there's really only three things the engineer needs to use to make the train move: the brakes, the reverser, and the throttle. The reverser, which controls forward and back, is moved to the forward position. Now, there are a couple of brakes, one for the whole train and one for me, the locomotive. They both are released. The engineer gives two short blasts on the horn to let everybody know the train's about to move. The throttle, which has 8 notches, is slowly moved forward. Wow, here we go! To stop the train, everything is reversed. The throttle is slowly lowered, the brakes are applied, both the train brake and the locomotive brake. Once the train comes to a stop, the reverser is placed in neutral. You want to back up? The reverser is put into reverse, the brakes are released, and the engineer gives 3 short blasts on the horn to let everybody know the train is backing up. Then, the throttle is slowly clicked into position. Either direction, this train is on its way.
Hey, isn't it awesome when a train goes roaring past? Wow, that train must be flying. Did you ever wonder just how fast that train is going?
Not really.
Wait. Before we talk about speed, maybe we should know what we're talking about.
We should not.
We
How
usually
fast is
measure
it?
speed in miles per hour, or mph. That's how far you can travel in 1 hour. The more miles per hour, the faster your speed. It's like this. When you're traveling in your bus to school, you might be going about 30 miles per hour. That means it would take you 1 hour to drive straight from Philadelphia, Pennsylvania to Trenton, New Jersey. When you're in the family car on the highway, you're going about 60 miles an hour. That means it would take you 1 hour to drive straight from Denver, Colorado to Colorado Springs, Colorado. So now that we know what speed is, we can talk trains. Here, look at this. When the locomotive was first invented way back in the 1820s, a steam engine called the Tom Thumb carried passengers at a speed of about 12 miles per hour. By the 1850s, passenger trains were going almost 25 miles per hour. By 1900, trains moved at nearly 50 miles per hour. Today, it's important to make sure everyone on the train and around the tracks is safe. So trains have speed limits, just like cars on the streets and highways. In America, freight trains can't go any faster than 80 mph, and trains with passengers can't go any faster than 90 miles per hour. Usually, when you're waiting at a railroad crossing, the trains are going about 40 or 50 miles an hour. In other parts of the world, some trains run on special magnetic tracks called maglev. At times, they can travel at speeds as fast as 370 mph. Wow, that's crazy! Easy. Well, now you have some idea of just how fast the trains you see are going. Remember, be safe. When you see tracks, think trains. So long! Hi. Trains like me make a lot of noise. The loud motor that helps me move the cars behind me, along with those cars and the clickety-clack of their wheels. But the noise you probably hear the most is my horn when it blasts out. You know, years ago, before trains had radios in them, whistles and horns were the only real way the engineer and other people on the train could talk with other trains. Now, even though all trains have radios, they still use the horn to communicate with anyone near them. Did you know there was a code to all those horn blasts? What can they mean? The engineer uses short blasts and long blasts of the horn in combinations to mean different things. For example, one long blast means stop, the brakes are on. Two longs mean release the brakes and go ahead. Three short blasts mean get ready, the train is backing up. Four shorts mean repeat your signal. I didn't understand. Here's one you probably hear all the time. Too long, a short, and a long means the train is approaching a signal crossing, like when the gates are down and you're sitting in the car waiting for the train to go by. Many short blasts means danger. There are people or animals on the tracks, and they must get off immediately. Trains also have a bell that rings when they're getting ready to move, approaching a crossing or a passenger station, when going through a tunnel, or passing another train on the track next to it. So The next time you see a train and hear the horn, you can tell everyone that you know just what it's saying. Hello. Trains are cool and fun to watch, but you have to be careful whenever you and your family are around trains and train tracks. Safety is important. You know, every 3 hours, a person or vehicle is hit by a train. So, when you see tracks, think train. There are all kinds of signs and signals to let you know when and where there are trains around. Want to see them? Okay. Just look at me. When you see a round yellow sign with a big black X on it, that means the road you're on has train tracks up ahead. It means you should slow down and look and listen for any trains that might be coming. There are also big markings painted on the road that also warn of train tracks ahead and where cars should stop safely. At the railroad tracks, there's a crossbuck, a big white X with the words railroad crossing on it. Just like me, the yellow warning sign, it means to look and listen for a train before crossing the tracks. There might also be a sign below it showing how many sets of tracks are at the crossing. Nearby, there should also be a rectangular blue sign with a phone number on it. If your car should get stuck on the tracks, get out immediately and call this number. This is the first number you should call, but if this sign isn't around, call 911. Many railroad crossings have lights and a bell along with the crossbuck. When a train is coming, the red lights flash, the bell rings, and if there are gates, they come down across the road. It is illegal to drive around lowered gates, not to mention very, very dangerous. Some roads with a lot of traffic have an additional set of flashing lights mounted up high on what's called a cantilever. This lets everyone, cars, buses, and trucks, to see when there's a train coming. Safety is important even if you're walking or riding your bike or skateboard. Never walk on or along railroad tracks. It can take a train more than a mile to stop when it's running, so if you can't get off the tracks for any reason, you could be in big trouble. Anyway, railroad tracks, rail yards, and trains are private property, and you're not supposed to be on them anyway. Never dash across the tracks as soon as a train passes. There could be another one coming from the other direction, and you'd never see it until it was too late. Wait until the gates go up and the lights are off before crossing the tracks. Trains are fun to watch, and they carry people and all sorts of goods all over the country. But being too close to them can be dangerous. So when you see tracks, think train. Hi, I figured you might also want to know what all those different cars are that you see a big engine pulling in a freight train. I can show you. Just look. At the front, you've all seen the big diesel engine. It's big and powerful, and it pulls all the cars behind it. And here's what used to pull train cars years ago. It's a steam engine. Instead of a diesel motor, it uses steam to power its big wheels. This is a hopper car. It can be covered or open. Covered hoppers can carry dry foods like sugar, rice, and flour. Open-top hoppers have lots of room to carry coal, gravel, and sand. When they unload a hopper car, doors open underneath to free up the stuff they've been carrying. This is a gondola car. It's open on top and is used to carry thousands of pounds of scrap iron and other raw metals. The gondola can also carry logs, lumber, and other cargo. We've all seen the boxcar. It has doors on the side that allow the loading and unloading of all kinds of things. The boxcar can carry everything from dog food and paper to canned goods and beds. Sometimes the loads can be as much as 100 tons. A different kind of boxcar is the refrigerated boxcar. Just like the refrigerator in your kitchen, this boxcar keeps foods cold. They can carry fresh fruits and vegetables, meats, seafood, and cheese. The tank car holds all kinds of liquids. It can carry thousands of gallons of chemicals, water, fuel like gasoline and diesel, and even molasses. This is the flat car. It can carry pipe, logs, lumber, tractors, steel plates and beams, and rails. How big are flat cars? They can be anywhere from 60 to 90 feet long. Wow, that's big! Special flat cars are called container cars. These containers, which hold all kinds of cargo, are transferred from trucks to trains and back again. That process is called intermodal. This is an auto rack. It carries cars and vans and trucks. They're usually covered so the vehicles don't get hit with rocks and other things along the way. A full auto rack can carry more than 18 vehicles at once.
Wait.
Here's a
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 18.
special car called a center beam. It carries heavy building supplies like lumber, wallboard, and fencing materials. The center beam keeps the materials safe and unbroken along the way. For many years, the last car of a freight train was the caboose. It was kind of a traveling office for people who worked on the moving train. It was also like a home away from home for those workers. There were simple cooking and sleeping facilities, perfect for long trips across the country. But around 1980, technology and computers made a caboose no longer necessary. Instead, a small radio called an EOT, end of train, is attached to the last car and automatically checks things like brake pressure. Well, that's a lot of train cars. But the next time you're watching a train go by, you'll know what each of those cars are and what each one is carrying. Remember, be careful and be safe around trains. So long!
If you live in a big city, and even if you don't, you've probably seen trains like this. They're called rapid transit trains. When the tracks go underground, it's the subway. When the tracks are up over the streets, it's the elevated, or L train. In the late 1800s, America saw a couple of big changes. One, bigger business meant the growth of big cities like New York, Boston, and Chicago. Two, many of these urban areas became electrified. That meant more business, more people, and more traffic. The problem was how to move all these people quickly and efficiently. Horse-drawn streetcars were slow, smelly, and held a limited number of riders. Also, more and more gas-powered cars clogged the streets, making the problem of moving many people harder. One answer was to get off the streets and go under them. In 1894, Boston started the first subway system in America. New York soon followed. Tunnels were dug under the city streets with rails laid for electric-powered train cars. Around the same time, Chicago figured, why not go up as well? They built an elevated system called the L in the downtown area known as the Loop. The tracks were over the streets, allowing road traffic as well as rapid transit. Everybody knows a train runs on two tracks, but guess what? Rapid transit trains have a third rail. Why? That's where they get their power to run. These trains run on electricity, hundreds of volts that move through a contact shoe that drive electric motors attached to the wheels. And that third rail is dangerous. Stay away from it. Two or more cars make up a train. They move from station to station where passengers hop on or get off, going to and from school, work, shopping, and more. The riders have to be quick. The train stops, the doors open, and in less than a minute, they close. The train heads off to its next stop. Today, many cities all over the world rely on mass transit systems to move people from one place to another quickly and safely.
Thank you.
In America, cities like Washington, D.C., San Francisco, Detroit, and Salt Lake City, along with long-timers like New York, Boston, and Chicago, all proudly boast about their subway and elevated trains. Rapid Transit, come on and get on board.
Hi, how are you doing? You know, it doesn't matter whether you live in a small town out in the country, in the suburbs of a big city, or that big city itself. There's all kinds of train cars that carry people back and forth every day. Would you like to see them?
No.
Here. Years ago, before jets flew in the skies, passenger trains took people from one side of the country to the other. The trip took several days, but the travelers ate the best of foods in the dining car, slept in comfy beds in the sleeper car, and enjoyed the view from observation domes. Today, a cross-country train trip still takes 3 days, but most likely, the passenger trains you see are taking people on shorter trips from one area of the country to another. These are called regional routes or commuter lines. For example, folks in Central California have Caltrain. The route of 80 miles runs from south of San Jose up to San Francisco. More than 60,000 people ride Caltrain every day, going to work, to shop, even to see the San Francisco Giants play baseball. The passenger car usually has 2 levels, upper and lower. On commuter cars like Caltrain, there are rows of seats for people to visit, read, or just look out the window. People usually get on through doors in the middle of the car, and you can go from car to car through doors at the end. With passenger cars, you might have a coach car. It has rows of seats, much like a jet airplane has. As many as 60 people can sit in the coach car. The lounge car has chairs where travelers can relax and look out from the upper level. The dining car is just like a restaurant on wheels. It has tables where folks can eat and a full kitchen to cook their food. The sleeper car has seats that fold down at night into beds, where people fall asleep to the clicking of the rails. If you haven't done it already, maybe you can take a ride on a passenger car, across the city or across the country. It's a great way to travel. See ya! Hello there. Let's talk trains. We all know that trains run on tracks.
We do.
Would you have any idea how many miles of tracks there are in America? Yes. 5,000 miles? No. 10,000 miles? No. 100,000 miles? No, but you're getting warmer. There's more than 200,000 miles of railroad tracks in the U.S. Wow, that's almost enough track to stretch from the Earth to the moon. Well, how do those tracks get there? Nobody woke up one morning and poof, the tracks were just there. Somebody had to build them. Here, let's take a look. Usually, a mound of gravel has to be laid first. That's called ballast. Then, wooden or concrete crossbars are put down. They're called ties in America, but they're called sleepers in Europe. Then, steel rails are laid down across the ties and fastened down. It's hard work and takes a lot of time. Back in the 1800s, teams of workers did everything by hand. They would drop the ties on the ballast, then drop the rails down and fasten them with spikes. These men were known as gandy dancers. In the late 1800s, a man named Robert Hurley designed a machine that laid ties first, then laid track. But even with a machine, as many as 25 or more workers were needed to get the job done. Today, machines still do the heavy work. A tractor pulls the first flat car, which lays down the ties at just the right spacing. Then, rails from a second car are fixed onto the ties. As many as 10 ties per minute are laid down. And these huge machines will lay down as much as 1 mile of track in a day. Pretty cool, huh? Machines just like these are used to fix and replace tracks too. So next time you see a train go roaring by, you can tell everyone just how those tracks got there. Remember, be safe. When you see tracks, think trains. See ya!
Bye.
Hi, it's Carl, the train conductor. I'd like to tell you all about my job. First, you'll know I'm the conductor by my uniform. I wear a hat and usually have a name badge. My job is to make sure the train runs the right way according to rules, like making sure I'm alert and pay attention to the train when I'm on the job. And I watch for signals along the rails. By using a radio, I keep in touch with the engineer, other conductors, and crew members, and the stations along our route. I also collect everyone's ticket and call out the names of our stops so you won't miss yours. Above all, I make sure everyone on the train and around the train is safe. Being a train conductor is a great job, and I hope to meet you the next time you take a train ride.
Hi, here we are, talking all about trains. You may hear people say, "Hey, keep it together." On trains, that's easy. To keep all the cars together, Here we are, talking all about trains. You may hear people say, "Hey, keep it together." On trains, that's easy. To keep all the cars together, they use what's called a coupler. Let's take a closer look. A coupler is a mechanical device that connects two cars to each other. They're safe and sturdy. Wouldn't want a big boxcar to come loose somewhere along the tracks. When trains first crossed the country back in the 1800s, the first coupler was called the link and pin. A big iron link was held in place to the car on one end by a strong metal pin. The car would be nudged close to the next car, where the link slipped into a socket on the end. Another metal pin was placed into the socket, holding the link in place. But the link and pin was dangerous. Someone, usually the switchman, had to get between the cars to insert the pins in the sockets. You can just imagine all the accidents that happened in those days. In 1879, a man named Eli Janney invented what he called the knuckle coupler. Why knuckle? Because the device looked like the knuckle of the finger. Over time, a number of people worked to improve on Janney's invention, but it basically has stayed the same all these years. The knuckle coupler is safe. The switchman doesn't have to get in between the cars. A lever on the side of the car releases the coupler. How much does a coupler weigh? They're about 80 pounds. Wow, that's about as much as 4 big watermelons. And what do they cost? A modern-day coupler is between $300 and $400. So, now you know just how those long trains keep it together. With couplers. See ya!
See ya.
Hello there, I'm Roy. I'm a cable car in the great city of San Francisco, California. Ever wonder how streetcars and cable cars like me run? Just look. Once upon a time, streetcars were found all over the country. As cities grew, people needed a way to get around. Streetcars, also called trolley cars or interurban transit,
What about those cars?
took
I've never
folks
heard
to
about
work,
those trains.
to shop, or to school. How does the streetcar work? Rails are set into the streets. The streetcar has wheels, like a train, that fit into the rails. Where does the power come from? It's electric. A pole gets power from overhead wires. That power runs an electric motor on each set of wheels.
Left, guys.
While not every street has rails, the streetcar goes wherever the tracks go.
No.
A cable car also runs on tracks, but it's moved in a completely different way.
That looks like fun,
Along with
actually.
rails in the street, a steel cable is set in a groove. The cable is pulled by big motors in what's called the powerhouse. When I grip the cable, I get pulled in the direction the cable is going.
I was wiped out.
The cable car reaches a turnaround, where it's turned around by hand, and goes in the opposite direction. These San Francisco cable cars have been part of the city for more than 140 years. In fact, cars just like me were made a National Historic Landmark in 1971, joining others like Hoover Dam, Pikes Peak, and the Empire State Building. While you might have to come out to California to ride me or the other cable cars, the streetcar is still around many parts of the country today. Cities like Boston, Cleveland, New Orleans, Philadelphia, Seattle, Atlanta, and many more have them. Streetcars and cable cars are a great way to travel around a town. See if you can find one and hop on.
I can sense it. Oh,
Hi there, I'm Kirby. Kirby Caboose. I used to be part of every freight train that ran in America, but not anymore. I got replaced by a little red light. But hey, you can still find me on train layouts and toys all over the place. I'm right there on the end, but you know what they say, save the best for last. That word caboose, it sure is funny. Where do you think it came from? Well, it came from Europe. Back in the 1700s, a caboose was the galley or kitchen on a sailing ship. When trains started crossing the country in the 1800s, the word caboose was given to a small shack on a flat car. That's where food was cooked for the train's crew, just like on the sailing ships. Before long, the caboose was a traveling office for the conductor, brakeman, and flagman who rode the trains. In the 1860s, someone got the idea to add the cupola, a second story, to the top of the caboose. From there, the conductor could see the entire train in front of him. Along with being a kitchen and office, the caboose had sleeping bunks for the long trips through the country. You gotta admit, there were a lot of uses for these cabooses. Around 1980, technology spelled the end for the caboose. Brakemen and flagmen were no longer needed on trains, thanks to electronics and computers. As trains became longer with more cars, the conductor couldn't see all the way to the engine anymore. Instead of the caboose at the end of a train, a blinking red light is now seen. They call it FRED, flashing rear end device, but it sure doesn't look like any FRED I've known. The radio device is also called an EOT, end of train, and is attached to the last freight car. The engineer gets all the info he needs about the entire train from the EOT. Today, cabooses can be found at railroad museums across the country. Many offer tours that show how trainmen lived and worked many years ago. See if you can check one out. Tell them Kirby Caboose sent you. Bye.
I'm gonna
museums across the country. Many offer tours that show how trainmen lived and worked many years ago.
Okay, well.
See if you can check one out. Tell them Kirby Caboose sent you. Bye.
There's no way they can make something in a minute.
Hello, everybody. This is Carl the conductor, thanking you for letting us help you learn all about trains. All aboard!
I hope you guys enjoyed this video. Super tired, not really, but hey, it's the end of the video. I'm gonna post this on YouTube. Hope you guys enjoyed, and of course, if you guys watch the whole entire video, hashtag watch in the comments below, and also, you guys, any of these people, tell me in the comments below, and I'll see you guys next time. Bye, guys. I gotta end it.